This is a summary of section 3.2, which considered continuous random variables. First of all, a random variable is continuous if its support set script A is an uncountable set. Second, the manner in which the probability is distributed over the support A, and this is where you come up with the notion of probability distribution. For a continuous random variable x is characterized by its probability density function f of x. Now in most situations we run into, f of x will simply be written as lowercase f of lowercase x. But occasionally we're going to have a second random variable x and y, and in that case it might be important for you to know which random variable f is referring to, and in that case we throw in an extra subscript here, which is an uppercase x as a subscript, and then have the lowercase x as an argument. All probability density functions f of x must satisfy the two existence conditions. First of all, they must integrate to 1 over their support, and f of x is greater than or equal to 0 for all real x. Finally, if you have some set A, which is a subset of the support script A, and you want to find the probability that x is an element of A, then what you can do is you can integrate over that set A of the probability density function dx. As a special case of that, if A and B are real values satisfying A less than B, then you find the probability that the random variable x falls between A and B by integrating f of x from A to B. Or if A happens to be a real value, then the probability that x will take on that one real value is equal to 0. Now, one final thing before we leave continuous random variables behind, and that is, don't forget the support. This is sometimes happens when people are learning probability the first time. For example, if I write f of x equals 1/3, that doesn't mean anything. Without some support over here, you don't know what the meaning to that is. And I'll give you an illustration here. Let's let f of x equals 1/3 and another f of x equals 1/3. Well, in one case, you could say this is for x equals 1, 2, and 3, and now you have a discrete distribution. In another case, you might say 1 is less than x is less than 4, and in this case you have a continuous distribution. But the key is, whenever you specify a probability mass function or a probability density function, you have to write the support off to the right.